Let's modify the previous tutorial so we can make a full screen bit blit. In other words, we want to take a bitmap in memory represented as an array of unsigned integers and paste it to the screen in regular intervals. I've added bookmarks where code has changed since the previous tutorial. This function is self-explanatory. I will not explain it. Our global state object, the variables from the previous tutorial with comments stripped out, the new variables, width, height, and all for the dimensions of our pixel buffer. I'll have to go over some of the things we've already seen because I want you to see it in the entire context. Win main you should be familiar with. Initializing our function pointer library. The window class we need to fill out. Registering the class. Creating the window. The timer that lets us update the window in regular intervals. Show window, update window. And here's our new code. GetClientRect. This gets the client region of the screen, which is the area of the window that you should be drawing to. It excludes things like title bars and borders. GetClientRect will fill out this rectangle struct, which has the members right, left, bottom, and top. We then can use the formula right minus left plus 0 to get the width. And for height, bottom minus top plus 0. The reason it's plus 0 and not plus 1 is because right and bottom are exclusive, meaning they're outside of the region of the rectangle. The reason I use plus 0 instead of something like this is because if I see lines of code like this, I think it's a mistake. I think somebody forgot to put the plus 1. But the Win32 API doesn't work like that, so I put that as a reminder that it is not a plus 1, that it's nothing. If you're writing code with other people, it might be nice to put a comment here, just to let people know what that is, because it does look a little bit weird. But for me, it's helpful, and consistent habits are always better than a good memory, because code just gets complicated and spirals into thousands upon thousands of lines. You can't remember everything you've done. You gotta have good habits. Anyways, here's our pixel buffer that we're allocating. I call it pixbuff. ColorRef resolves to an unsigned integer, 32 bits wide, right? So it can hold the A, R, G, and B bytes, right? So that 8 bits per byte. So 8 times 4, 32 bits. And this is 32 bits. This is going to be 4 bytes times the width times the height. And that's going to allocate all the memory we need, and it's going to shove it into pixel buffer. Once we've done that, we're going to loop through every single pixel, represented as one unsigned integer, right? So each one of these in here is an unsigned integer, and we're going to set that unsigned integer value to this, right? The A channel is 0, R is 32, G is 32, and B is 32. This 32 is a hex value, not a decimal value. I have no clue what the decimal value is. I don't care. You can look it up. It's easy to convert. All right. So here's usage of that self-explanatory function. Create bitmap will return null if it has failed. So I just wrap the call with this to notify me. Here's a little reminder to let me know that this is bits, not bytes, for this parameter. Select object, we've already been through. The message loop. Update bitmap, we've seen this function before, but we've added a lot of new code. Don't be intimidated here. A lot of this is just variable declaration. We have pixel A for alpha, R, G, and B. These are the individual components of the pixel, which we are going to bitpack into pix. We're going to loop through all of the pixels. PI stands for pixel index. We're going to use the index to XY formula to get the X and Y coordinate from each individual index. After we have the X and Y coordinate, we're going to use some logic to paint a different color on each quadrant of the screen. So if we are on the right side of the screen, we're going to have full intensity red. If we are on the left side of the screen, we're going to have no red at all. If we are on the bottom of the screen, we're going to have full intensity green. If on the top of the screen, no green at all. So I think it would be good to run the code now, since we're going over the logic that paints the screen. Let me drag this over so you can actually see it. So here you see that the green is at the bottom. And you might be wondering, why is the green at the bottom? Because py greater than height divided by 2, wouldn't that mean it's on the top? Well, in graphics, the origin is at the top left. X, as you would expect, increases as you go to the right, but y increases as you go down the screen, like this, right? It's very common in graphics for that to be the case, and it makes things easy to work with. So just expect it to be that way when you're doing graphics. Anyways, let's keep going. So here is where we bitpack each component, alpha, R, G, and B, into the pixel. The alpha byte needs to be shifted over 24 bits, the red byte 16 bits, the green byte 8 bits, and the blue byte is already where it needs to be, so it's not shifted over any. This might look a little bit weird with the shift 0, but once again, it's just one of those weird things I do to remind me that it's not a mistake, that I didn't just forget a number. You know, I explicitly say 0. After we've bitpacked that pixel value, we're going to shove it into our buffer at that index. If this line of code right here on line 293 doesn't make any sense to you, it looks kind of weird, then you need to review bit packing and bit shifting in C or any language that supports that abstraction. This line is very straightforward. If it doesn't make sense to you, it's probably just because you don't have the background knowledge, but I can't go more into that because that's not what this tutorial is about. So let's keep on going. So here we have set bitmap mips. Why can I not pronounce that? Set bitmap bits. We've gone over this before. This time we're going to set the pixel buffer. In the Windows procedure, which you've seen before, we have code you've seen before. Let's keep on going down because there is something new. Alright, so we're not looping anymore. The X and Y are just going to stay at 0, and we're only going to do 1 bit blit instead of 4. Right? And that 1 bit blit is going to cover the entire screen. So you can see this. This is 0, 0. And then right here is the width of our buffer and the height of our buffer. Now let's scroll through the rest of this so you can see everything in context. Our default Windows procedure that's called after we do our custom behavior. And then some credits. Alright, with that, I'm going to go to the build script right here. So you can pause on that and see how this project is built. And you can always email me if you want the source code for this project.